Okay, friends, I will start with my first today's lecture. I hope I am audible to all of you. Now, today I told you that we're going to start with the new concept called as flowchart. So let us see what is this flowchart means. Okay, today we will start with the concept of flowchart. So let us see what is the definition of flowchart. The definition of flowchart is it is a diagrammatic or symbolic presentation of an algorithm or problem solving method is called as flowchart. That means what? Whatever the problem solving method you are adopting, that you have to represent by using certain symbols, by using certain diagrammatic approach. Or in other words, you can say the algorithm as such, the stepwise procedure as such, we have to convert in terms of certain symbols. So natural question comes, what are those symbols? Which are those symbols? What is the meaning of these symbols? And for what purpose these symbols are used? So let us come to another slide. See the first symbol, which is like a ovule. This is the symbol like a ovule. This symbol is used to show start or end of the algorithm. We know that every algorithm has start and end exactly once. So this start and end is shown by hello Aleka. काय मी डिपार्टमेंट आहे काय नाही लेक्चर चालू केलं आपण ठेवायचं हो 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 काय प्रॉब्लेम येस the symbol ovule is used for start and end. See, this is another symbol which we call usually as a parallelogram. So this parallelogram is used for input and output. So to give the data and to take out the result for these two activities, uh, the symbol parallelogram is used. Now these are the two another symbols which are either a square or a rectangle. So you can use any one, square or rectangle. And the main purpose of this is to show procedure, to show calculations, to show method, to show problem solving process step by step. So that is the meaning of these two symbols. You can use any one. The another symbol, it is called as rhombus. In geometry, it is called as rhombus. And this rhombus is used for decision making. When you have answer yes or no, when you have two or three answers, options, choices, in that case, we have to use this decision making box rhombus. And these are the arrow lines. These are the flow lines. Data is coming from one side going to other side. What is it? Data is coming from this side going to this side. Data is coming from this side going to this side. Data is coming from top going to bottom. From this side to this side. Data is coming from this side to this side. So for such activities, these different symbols are used. So remember, there are only 1, 2, 3, 4, 5 symbols are there. Basically, main symbols are 5. And based on these 5 symbols, we are going to draw what is called as algorithm, and we are converting this algorithm into a flowchart. So I will give you two examples of flowchart here. Okay, now this is the flowchart for addition of two numbers. The most simplest flowchart I am showing here. As usual, see the very beginning is start. As usual, see the end. At the end, it is end. So start and end are shown by a ovule symbol, right? Now we want to add two numbers A and B. So that is why data input is A and B. And so I have used what is called as parallelogram. And this parallelogram has the instruction give values of A and B. So this is the data input. Once data you have, then you are in a position to add them. And so to add them, we have to use rectangle or we have to use square. And there we have to mention that C is equal to A plus B. Now this C is equal to A plus B has two operations. The first operation is addition of A and B. And the second operation is whatever the result of A and B, addition of A and B comes, that is stored in C. So calculation and storage, these are the two operations taken place in C is equal to A plus B. Now once you have C, that means you have input and you have result also. So our job is over. So we are going to take the output. And so output means again we have to use parallelogram. So in parallelogram I have written display values of A, B and C. That means I am expecting the value of A and B which are input and the output as C. So once I have done this, my job is completely over and I will write end. So this is the symbolic representation of algorithm of addition of two numbers. I will show you another one algorithm flowchart. And this flowchart is for sum of observations. Yesterday we have written its algorithm. Now today we are writing its a flowchart, sum of observations. So let us see. The first step is start. If you see the very last step, it is a stop, means end. So ovule is used for stop and start, start and stop. As we know that sum of the observations x1, x2, xn, what is the size of the data? N. So what I am writing here is in the parallelogram, give the value of n. So that is my first data input. Give the value of n. Next step is I am initializing my account sum by 0. So it is like a zero balance account. Sum is equal to 0. It's initialization. So initialization is a process. I am putting the value 0 to the variable sum, and that is why it is a process and rectangle is used. Thereafter I am showing I is equal to 1. That means the value of I am beginning with 1. So it is again a process, and so rectangle is used. So I is equal to 1 means I will start with value x1, give the value of xi, give the value of x1. And once I have got the value of x1, I will perform certain process that leads to sum, and that process is sum is equal to sum plus xi. So I am updating my account. The previous value of sum is added with xi, and the new result comes will again be stored in sum itself. So it is an updation of account sum. Thereafter I will switch over to second observation, and by second observation means I is equal to I plus 1. So I may switch from first to second from second to third, from third to fourth. Like this, I have to switch from n minus 1 to n. And after n, there are no observations. So I have to check every time whether I is less than or equal to n. So it is a decision box. If I less than or equal to n, I have to repeat the steps. If I is greater than n, I don't have to repeat the step. So there is a decision. And that is why I am checking here whether I is less than or equal to n. Now if I is less than or equal to n, means if this condition is true, yes, I is less than or equal to n. That means there are few more observations yet to add. So I will go back here. I less than or equal to n. Go back here. Give the value of xi. So give the value of x2. Give the value of x3. Give the value of x4. Give the value of xn minus 1. And lastly, give the value of xn. So this is called as, in fact, a loop. So these steps are performed again, 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 and again. It is called as loop. It is like a cycle. So you can see this is like a cycle, right? So this, you are coming back when there is a yes answer to this condition. And when this condition carries no answer, you are coming this way. And no answer means I is greater than n. So I greater than n means my number of observations are over. And once my number of observations are over, I am in a position to get the sum. So display sum is my output, which is I am taking you by the help of parallelogram. Once I get the output, I will stop here. So this is the flow chart for some of the observations. So see, ovule is used exactly twice. One is at the start point, other at the stop point. Parallelograms are used at many places. Procedure rectangle is used at many places. You may use decision box at many places. But start and stop must be exactly at once, because your algorithm, your flowchart should start at one point and it should end at one point. So that is what the concept of flowchart is. So try to understand that these are the basic symbols. Try to understand that this is the basic definition. Diagrammatic or symbolic presentation of an algorithm or problem solving method is called as flowchart. If you see this is the list of symbols and they are used for certain purpose. So that is what I have given. This is one example, this is another example. So with this, I suggest you to write down many more algorithms. Second suggestion is convert every algorithm to flowchart using these symbols. You have to do the practice of this, because even if I write hundreds of algorithms, if I write hundreds of flowchart, that makes no use unless you write your own algorithm, unless you write your own flowchart. So that is why I try to understand the concept as such and try to draw your own flowchart. By the way, in this flowchart, if you have any doubt, you can ask your doubts. So it's a time for your question. If you have any doubts, if you want to any question, you can ask. I will mute all of you. You can unmute and you can ask your questions. If you have any question, you can ask. Any question? No question? No question?